Our third speaker of this second session is Chris Berryman, and he's TENTION Technology International, which is all about ropes, which is very useful to know on STS operations. So hopefully we'll be going to learn something as well here. He's an expert on the use of marketing-leading mooring analysis software, Optimore. He's previously was a design manager for Marine and Offshore Division of Europe's leading rope manufacturer. He's a graduate physicist, trains in rope making. Sounds like an Indian rope trick or something, but yeah. Chris has run approximately 100 Optimore studies per year, including ship-to-shore mooring analysis. And obviously, takes most of your business at the moment, is this, or only business. And he's also an instructor running about 15 courses per year worldwide. He has a very thorough and broad experience of the rope industry, including development of yachting and other leisure craft and fishing industry. So, Chris, please.
Thank you. Good afternoon. Can you hear me? It's all switched on. Right, I'm giving a presentation on Optimore. Optimore is mooring analysis software. We write the software and we sell it, and we run studies for people, and we train people how to use it. I've been asked to give a presentation on the use of Optimore for ship-to-ship mooring analysis. There are several types of ship-to-ship mooring. There's four main ones there, with the host connected to a shore berth, or with the host connected at anchor, with a single anchor or with multiple anchors, with the host connected via a tower yoke, and with neither the host nor the guest connected to seabed or shore, so an underway ship-to-ship mooring. So here's a typical ship-to-ship mooring with the host moored to the a shore berth. So simply the blue circles are bollards or dolphins or hooks. The green boxes here are the shore fenders, and then we have our guest, and the turquoise boxes there are ship-to-ship fenders, and the black lines are targets. This is a host anchor, so an overview and a close-up. So the overview shows four sets of four anchors. So now the blue circles, instead of being bollards or hooks or dolphins, are now anchors on the seabed. This is a turret moored simulation, so you can see the 16 chains go from one point from one point on the host, and then we have the ship-to-ship connections there. So there's a very large LNG based on the Prelude example, which we've done a lot of work with Shell over the last few years. And another type of host anchor would be a single anchor. So here we have a single anchor here, for which the host is connected, and the ship-to-ship connections as before. This is a tower yoke example. So there's a special collar here which represents the tower yoke, and then we've got the ship-to-ship connections as before. And finally, an underway simulation. So the host or guests are not connected to anything other than themselves, and then they're free to move according to the environment, or I've just put some thrusters on the back here, just for a bit of fun when I was setting that up. And again, Is that the pointer? Right, okay, thank you. And again, the ship-to-ship moorings as before. When you set up the line connections, you can have connections from guest to host, or host to guest, or a mixture of both. So we can see here we've got a mixture. The black lines represent wire, the orange lines represent tails and synthetics. If we had green, that would be chain. And you can also connect from either the host or the guest to the shore. So it's not just the host that can be connected to the shore, but the guest can be connected as well. In order to run an analysis, you need three basic sets of data. You need data for the berth, so the type of berth, the tidal data, the water levels, or regular tide data, or tidal charts. You need the layout geometry, so basically you're specifying an X, Y, Z position for everything, for the hooks, bollards, and dredge depth and heights and so on. And you need the fender properties, again the X and Y and Z properties, and the fender characteristics, so the reaction curve, load against compression, panel width, and so on. So that allows you to create a 3D model of a berth. And if it was at sea, then you wouldn't have the fenders. The bollard hook positions would be an X, Y, Z position of the anchor positions. You also need vessel data. So you have to create a 3D model of a vessel. So you need all the basic dimensions, windage data, flat side or parallel side data. You need to choose your wind drag coefficients and your current drag coefficients suitable for your ships. If you have waves, you need to select a wave motion data file. And you need the line properties and the drafts and the ship-to-ship fender data and positioning as well. And finally, you need the environment to apply. So that includes the drafts and the water level, maybe the GM, trim, and then wind, current, wave, swell, and so on. So while that might sound quite complicated to initially set up, once you've created it for one berth, then of course that's there for good, and the next time a vessel comes to that berth, you've already got it created. And the same with a host vessel. So you create the host vessel once, so chances are on a new case, you just have to create the data for the guest vessel, because that will be new to that berth. This is the environment window, what we call the environment window. So we can see here we enter draft, trim, water level, GM. We can enter the side of vessel facing up according to the drawing that we have in Optimore. The offset of the vessel relative to target. And then we can enter the wind, so the speed and direction, the current, speed and direction. And then for the locally generated waves, the significant height, mean period, direction, and for far off generated swell, the same, the HS, TZ, and direction. There's an option to put longer period swells, harbour, seiche, or surge. The option to put other forces, such as a tug or a bank effect. And then we have similar data for the guest. Most of it's the same, but what may be different are the draft, trim, GM, side facing up, and offset. So that's what we call the general environment window. Then we have a berth window. So this is a shore berth as an example. So we have the angle of the berth relative to north, the width of water, the height, the dredge depth, surge sway and heave limits, offsets of target to origin, tidal data. And then for the bollards and hooks, we're specifying X, Y, Z data. So we have an X distance, Y distance, Z distance, maximum allowable load. And then for the fenders, we have similar X and Y, width, face area, and then we have 10 points, which are 10 points on a curve, a reaction curve, so 10 points describing the force and the compression at 10 points to allow Optimore to join up and produce the curve. So if this was a berth for open sea, then it'd be very similar. We wouldn't have the fender data. We'd be describing anchor positions. Right, slight problem. Thank you. Right. So that was the berth window. Here's vessel data. So this is host vessel. So basic dimensions: length, breadth, width, the X, Y, Z position of the target. So for gas, vapor manifold, center of the vapor manifold on both sides. You select the current drag coefficient data set here, the wind drag coefficient, the hydrodynamic coefficient files for waves. Behind here we have the parallel side data. So you have that curve plotted. So you've got an accurate reflection of how the fenders are lining up. Windage area. And then here we have the mooring line or fair lead numbers, and we enter the X, Y, Z positions of all the fair leads, the inline length of line, so from the fair lead to the winch or bits, the winch brake limit, pre-tension, and then data on the lines, so the type of line, the diameter, and the braking load, and with the tails and so on. So we can see all that data here, but if we were only receiving lines and not providing them, then we would need the minimum amount of data. So we see here we just need an X, Y, Z position of the fair lead, then the distance from the fair lead to the bits or the hooks. We don't need to provide any data for rope because it's not giving out rope, it's receiving rope. So here's an example of the parallel side. So we've entered our data in there, and then Optimore plots it up, and then we can see how the fenders line up. The green fenders are shore fenders, the turquoise ones are ship-to-ship fenders. And then we've got the hull pressure limit in there, and the gap between the ships when the fender is not compressed. And then for the ship-to-ship fenders, again, we specify the position, X, Y, Z, and the width and the face area, and then the load and compression data that allows that line, parallel side line, to be plotted. So here's the typical ship-to-ship fender curve. So a Yokohama type, 600 ton, maximum load, 2.7 metre maximum compression. So that's all the data we entered for the reaction curve, and then Optimore's plotted that there. The guest vessel data, well, that's pretty much the same as the host, but just according to the data on your host vessel. So this previous curve, parallel side curve, that is showing the fenders in relation to the host vessel. So on one side you've got the shore fenders, on the other side you've got the ship-to-ship fenders, but then you also have to line up the ship-to-ship fenders with the guest ship parallel side. So therefore that now just shows the ship-to-ship fenders in relation to the guest ship parallel side. You can look at the catenary. So if you have an anchor connection, we see here that red dot is the fair lead, the green line is the chain, and we've got the anchor down there, and then you can enter loads and see how the angle of the catenary varies. You can import graphics, so several graphics files, so you can import a graphic of the berth or the vessel or both. So a Google Earth shot, for example, makes a nice picture in your reports. So in this case, I've just got the berth here. And you can see, I mean, the reason you might do that is because it looks nice in your reports, but it's quite time consuming to get all that lined up. The reason I've done it in this case is because there was a lot of dispute and to-in and fro-in, which is not unusual, about what the actual data is. That's a common issue with people providing you with data. You're never quite sure how they've measured it. So when you put the picture behind, then you can see it all lines up quite nicely. So it gives your customer confidence that you're doing your study correctly. So the types of mooring analysis that you can do. Static mooring analysis. So typically that is just wind and current typically, but can also include wave drift forces and other forces like tugs and bank effect. And that's the sort of common analysis that is specified in OCIMF MEG 3, where they say run a 60-knot wind from all directions with currents at set directions and speeds. So that gives you a nice bit of security if your vessels pass with a 60-knot wind, but it's not very realistic because winds just don't blow at 60 knots and nothing else. They vary with time. So a static analysis just gives you that insurance. So important to note is really without waves. For waves, you add a seakeeping or wave response module in Optimor, and that calculates the first order vessel motions due to the waves and calculates what's going to happen in a 3-hour period, either the maximum effects or the significant effects. And finally, you have the dynamic analysis in Optimor. Dynamic has nothing to do with waves, it means time varying. So now, instead of running a static analysis, you run the analysis over a period of time, any period of time. So it could be 2 minutes, an hour, 3 hours, a week, a year. And this is a much more accurate way of modelling what's going to happen, but it's also more time consuming, more complicated. To run a dynamic analysis, because you're running it over a period of time, then you must have time varying inputs. So you can't have a static wind speed of 60 knots and a static draft and static current. You can do, but it's pointless. So you'll have at least one input that's variable. So the wind, the current, the draft, and so on, water level. These inputs will vary over the time which you run your analysis. So for a static mooring response with the seakeeping, this is a typical screen. The key things you're looking at normally are the movement of the vessel. So host mooring response. So the movement of the host relative to the target it's aligned against. And we can see here, up here, we have the surge, forward and aft surge, sway, in and out, yaw and heave. Then the other key data is the tension in the line in tons, which isn't that useful at first look. What's useful is the percentage, that is, as a percentage of the weakest line in your mooring system. So we can see here, can't quite read, 17% perhaps is the highest. So we can quickly see, we know our limits are going to be 50 or 55%. And the third key lot of data is the fender data, the thrust, compression, and pressure. Now, when you set limits, then any data that goes beyond a limit will show in red instead of a black font. Other data, such as all the hook and bollard and chain forces, are shown here, and the 6 degrees of freedom due to the waves are shown here. So normally they're not as important. the key things are the movement of the vessel, the percentage of line load, and the fender data. Right, okay, and then the guest mooring response. So that was the host, this is a guest, so exactly the same principle. You can run wind roses, and current roses and wave roses as well, but wind roses are the most useful. So here we have the host and the guest. Sea state limit curves. So they're like wind roses in that the wind rose has a variable of direction and wind speed, whereas the sea state limit curve has the variable of significant wave height and period. And then you can see the limit, so the red line is, say, the 55% line load limit, and you can see for any wave height at any period, whether you exceed or not that limit, plus lots of others. So I'm showing there for the guest and the host. Dynamic analysis, so I mentioned that's time variable. So all the x-axes here are time. This is 3 hours. This is the variability of the wind, speed and direction, current, surge, yaw, and sway, X and Y forces, ship to shore fender curves, ship to ship fender curves. So you can see it's all varying with time and line loads. Because dynamic analysis is complex, to look at it thoroughly, you need to open it in a spreadsheet. So as an example of the spreadsheet, and you can show data of every variable down to every hundredth of a second. So it'll show you every line load, every bit of movement, and so on. So the key output data you would get are the line loads to make sure you maintain your 50-55% limits, and your chain horizontal and vertical loads, your vessel excursion and motions, so the host and guest movement relative to their target, and the fender loads and compression. So keep the ship to ship and shore load and compression limits, or within your limits on the fenders, and keep within hull pressure limits. And if you're interested, then we run training courses anywhere in the world. So normally you'd want a 2-day training course. Here's some real-life LNG examples: Toscana, Port Qasim, Portland Bight, the Hilly FLNG. And if you want a demonstration software, you can download it, a demo version, to have a play with. Okay, thank you.
Conscious of the time, but one quick question. Do you do post-incident analysis?
Yes, yeah.
From your experience, what has been the cause? Is it the poor quality of the mooring lines, the fenders, what's...
In my experience, the mooring lines are always in a less than good condition. For all the investigations I've done, people don't inspect their mooring lines. They generally don't know how to do it. I did one last year. The total claim was $80 million. The lines were down to about 28% of their new braking strength, and the vessel crashed into the jetty and just totally wrecked it.
Yeah.
Yeah. So that is the most common.
Well, that
reason.
follows, my question leading on to that question that's been put by the floor there is obviously looking at stronger mooring lines and how much stronger they need to be for an SDS. But I thought a braking strain or mooring line is braking strain. So
you don't have different ones generally, and you're going to be governed by your hardware. You can't just up them. Yeah. Because you've got hardware strength restrictions.
Safe working load. NBL could not exceed safe working loads on columns. That's it.
That's it. Yeah, exactly. Any more questions from the floor? Otherwise, is it lunchtime? Obviously, people want to go lunch.
I've got a question. Oh. I just wondered to my colleague... Oh, sorry.
No, go.
In Malta, how do you know your ship-to-ship moorings are safe? You gave a whole range of environments, big waves in all directions. How do you know that's all going to be okay? For ropes, for example, vessel movement and the fenders.
You wouldn't have any input.
Mm-hmm.
You wouldn't have any input of the tension on the lines, so you just have to use
The lines that are available, you try to use as many as you can within the limits of the bits and the lines available.
In the last photo that you show us, I have this question. Do you use, as part of your standard STS equipment, a quick release unit connected to one of the ship's manifolds?
No.
So you rely on somebody being quick to disconnect the hoses in case of an emergency mooring.
That was the point, yes.
But if I'm not wrong, the OSIM guidelines actually provide or require that a quick release unit is fitted onto the manifolds.
No, the guideline says that tools for rapid disconnection are required to be at the manifold. So the OCMIF guideline for oil operations does not require a special fitting.
It
requires tools for rapid disconnection.
But it makes reference, and I think in the second last page of the OSIM guideline, it does provide or make reference to a quick release device. Because we are using these devices if we load out of an SPM these days. We connect the vessel with a hoser, then they connect the cargo hoses, which cargo hoses are connected to a quick release device. Why don't we use it as standard equipment on board, when you do the STS operations?
No, there isn't that requirement, not even in the checklist. So if you mean with a quick release, meaning the normal cam locks, like they're being used in SPMs or in terminals, it is quicker than a bolt. But my point was, who is going out there to release it? It is like the mice and the bell around the cat's neck. Knowing the solution, but who is going to release it? If you take that to the LNG situation, they can release it remotely, and both the manifold and the hose or the loading arm are closed before they actually disconnect.
Exactly.
In the oil industry, I've never seen that.
Yep. Okay, we'll have to
We'll discuss
discuss that
it
one
over
over lunch, I think. Maybe the next STS guide will clarify that very point.
Well, ask Captain Gordon.
Yeah. One quick question? Just one final question. Sorry, Alex, just one question, yep.
So the question is, don't you think that it's safer you minimize the number of lines, not just double the number of lines, which increases the workload for the crew, but also in case of emergency release, you have to spend double time in releasing the lines. So I'm asking the question because the question was raised to you. What is your procedure?
Minimizing the number of lines as mooring lines, or?
The mooring lines, yes. It's because from what I understand, what you have just said is that your strategy is based on we just reinforce the number of lines. This will make us to be sure, which means, well, I don't mind 4 or 5 lines break because I have additionals.
No.
This is my understanding from what you have just said.
What I will do is I use as many lines as I can because they are available. So there is no point in not using them.
But this is my question for you. Don't you think it's safer you try to optimize the mooring plan and then you use the minimum number of lines required just to make sure the crew don't have to stay that long in mooring both vessels, but also you minimize the time you need for releasing all the lines?
No, I don't see it that way. I strongly believe that my mooring lines are not there to fight the forces of the sea, as I have just said. So if I am anticipating that seas are going to be just a little bit challenging, I would just drift so that the load that my mooring lines will take would be just to keep me in position. I don't want to have a static ship, like a ship on anchor, and the other vessel resting on the mooring lines, whether they are 8 headlines, 6 headlines, or 10 headlines. I don't want to have that situation. Okay, so I'm not using my lines. I don't want my crew to go and release lines. No, I don't want to be in that situation. I want my lines only to keep the ship in position. And then to deal with the forces of the sea, I will either have to drift or make way. but I will not rely on the forces of the lines because it is simply a risk that I cannot control. I don't know what tension the lines are taking. No matter how much inspection I can do, I will never be accurate in the percentage breaking load that is already in the lines, so I cannot rely on things that I don't have full control of.
Okay, thank you. And the second thing is, I agree with him that the use of toggle pins is recommended by OCMS, MF, and this is the provider who should organize on board for the emergency release of the lines. And this should be fitted, not left on the manifold area, should be fitted on all lines. And the crew, I have used that, it's very simple to use, and it's a safer way to release the lines. Don't you?
The lines or the hoses?
No, the toggle pins for emergency release the lines.
For releasing the lines, yes.
Yes.
For releasing the lines. But the reference I was making there, tools at the manifold, is for the hoses.
We were
For the
talking
cargo
about,
hoses,
sorry, I
yes.
misunderstood.
Okay. To remove 12 bolts from the hoses with rapid releasing tools, it is normally understood on board to be pneumatic tools,
Okay, understand.
rather than hand spanner. It is not.
In
It is
terms
not
for the
enough.
mooring lines, do you usually use means for emergency release?
No, for mooring lines, yes. Using the toggle line, I agree with it. It is described in the OCIMF guide, yes.
Thank you.
Thank you, thank you. That's it. Well, that concludes session 2, but Alex now will give us more information about lunch and session 3.